Assalamu alaikum wa rahmatullah. How are you? How's everything? Today the lesson 11.1, which is read line plots. Read line plots. Let's watch the video first.
How can you read data in a line plot? A line plot shows data along a number line. Each dot above a point on the line represents one number in the data set. An outlier is any number in the data set that is very different from the rest of the numbers. The table shows the distance Eli walked his dog each day for 7 days. How would a line plot help you identify any outliers in the data?
Line plots make data easier to read at a glance.
What do you notice about the distances in the table? Most of the distances are close in length. Is there a piece of data that is very different from the others? Explain. Yes, Eli walked his dog much farther on Friday than on the other days. You can show the data on a line plot. The most dots are above 1 on the line plot. The most common distance is 1 mile. The longest distance is 3 miles. The shortest distance is 1/2 mile. How many dots are above 1 and 1/2 miles?
Select your answer.
So here we have some points. We should know them. The most dots are, this is, we should know it, that the most dots are above 1 mile, because some question he would ask you which mile or which, here it depends on the unit, which one is the most. So the most, we should know that which one has the most dots above any number. And the longest distance, which be the longest distance, which is here, the longest here is 3 miles. And the shortest distance is 1/2 mile. How many dots above 1.5 miles? How many dots? As we see here, 2 dots.
2 dots are above 1 and 1/2 miles. What do the 2 dots mean?
Let's try to know each dot. What does it mean?
Select dots in the line plot to see what they mean.
Okay, for example, these 2 dots above 1.5 miles.
Eli walked his dog 1 and 1/2 miles on 2 days.
So in 2 days. So as a conclusion means here, each dot means a day.
Eli walked his dog 1 mile on 3 days.
Here, Eli walked his dog 1 mile on 3 days.
Eli walked his dog 1/2 mile on 1 day. Eli walked his dog 3 miles on 1 day.
Let's continue.
Eli walked his dog 1 and 1/2 miles on 2 days. Why was a number line from 0 to 3 used for this line plot? All the data are between those 2 numbers. Identify any outliers. The dot above 3 is far away from the other dots on the line plot. The distance Eli walked his dog on Friday, 3 miles, is an outlier.
So the distance Eli walked his dog on Friday, 3 miles, is an outlier. We should know what is the outlier. So here in this number line, the outlier is 3 miles.
Will all sets of data have an outlier? Explain. No, some sets can have data in which all the numbers are close in value.
So if the sets can have some data in which all numbers are close in value. So if they are close in value, so it means there is no outlier.
Could a set of data have more than one outlier? Explain. Yes, the set could have one or more numbers much greater or much less than the other numbers.
So if I have a number much greater or much less than the others, so it means this is an outlier. Like 3 here, it's much more than the others. 3 miles is far away from 1.5, so it's not close to them, so it means 3 is an outlier. And in this number line, we only have one outlier, which is 3.
Now you know how to read data in a line plot.
Okay, let's move to the questions. Page 593. For 3 to 6, use the line plot below. Okay, question number 3. This line plot is talking about giraffe heights. We have from 14 feet to 18 feet. Question number 3. How many giraffes are 14 feet tall? As we can see in the 14 feet long, we have 2 giraffes. What is the most common height? The most common means which height has the most number of giraffes. As we can see, question in 15 feet, we have 3. So the most common height is 15 feet. Question number 5. How tall is the tallest giraffe? The tallest one is 18 feet. 18 feet. Question number 6. Is 18 feet an outlier? Explain. 18 feet is not an outlier. No. Why? Because 18 is close, or the values are close to each other. The values are close. For 7 to 11, use the line plot at the right. Question number 7. How many people ran 100-meter sprint? Okay, so this is a line plot about times 400-meter sprint. So how many people ran the 100-meter? Let's count them, all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So about 20 people ran 100-meter sprint. Which time was the most common? The most common that has the most number of people, which is 10, 4 over 10. Which time is an outlier? As we can see, in 11 seconds, it's far away and from the other values, so it is the outlier, 11, in the 11 seconds. 11 seconds. How many more people? When he asked me how many more, this means we should use minus. How many more means minus. How many more people ran 100 meters in 10, 6 over 10? 10, 6 over 10, I have 3. Then in 10, 1 over 10 seconds, I have 1. So 3 minus 1 equal 2 more people. 2 more. Question number 11. Curtis said more than half the people run 100 meters in less than 4 over 10 seconds. Do you agree? So he said that more than half the people, all of the people are 20. Half the people are 10. So more than half the people ran 100 meters in less than 10 4 over 10. 10 4 over 10, less than 10 4 over 10, which means these people. Less than 10 4 over 10. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. So 8 people. So do you agree? No, because only 8 people. 8 people ran less than 10 4 over 10 miles. Let's move to the next page. Use the line plot at the right. Question number 16, which is an outlier? 3 over 10. This is 3 over 10. No. 1, 2 over 4. No. 2 inches. No. So question, the answer is D. There is no outlier. Question number 17, which length of nail is most common? The most common that has the most number of dots. So it is 1, 2 over 4, which is C. Thank you for watching.